Hello friends, welcome to Biology Extrema, where we teach biology from the basics to the extreme. Myself Keshav Bansal, and today we are going to study about nomenclature in fatty acids. Okay. So before continuing our topic, I want to inform you that this channel Biology Extrema contains video in both Hindi and English languages. So if you want to see more biochemistry video in English language, so there's a special playlist dedicated to it, which is biochemistry in English. Okay, English is specified to it. So you can go to that playlist and watch all other biochemistry videos in English. So let's continue our topic. We are talking about nomenclature in fatty acids. Okay, so what is meant by nomenclature? It means how we name a fatty acid, the naming system, the rules with which we have to name a fatty acid. Okay, so there are two naming systems here. Number one is standard. Okay, the first one is standard system of classification, or we can say the nomenclature, and then second one is an alternative convention. Okay, alternative system, which is called omega system of classification. Clear? So first we are going to study the standard system of nomenclature. Okay, or we can say the standard system of naming. So let's start with the standard system. So if we talk about a fatty acid, we have two components. Okay, number one is a hydrocarbon chain, which is attached to a carboxylic acid group. Okay, a COH group. So let's draw a hypothetical fatty acid. Let's take COH and draw the methylene groups. First we are going to draw saturated fatty acids. Okay, and another thing I need to inform you that in this video we are going to discuss the topic that is nomenclature. So it will use a lot of other topics like water fatty acids, water cis fatty acid, trans fatty acids, saturated and unsaturated fatty acids. So we've already discussed all these topics in detail. Okay, so you can check out the playlist to, and it's better to first see those videos to gain understanding, because we are not going to discuss all those basics here. Okay, so we will take just a brief intro of all that. So I just said that we are going to use the standard system of classification. Okay, standard system first. So in a standard system, first we are going to talk about the naming, how we, or we can say how we number the fatty acid chain. Okay, so how we do the numbering according to standard system? So we assign carbon number 1 to the carboxylic group. Okay, the carbon of the carboxylic group, we assign it carbon number 1, and then the subsequent carbon 2, 3, 4, 5 and so on. Okay, lastly carbon will be methyl group. Clear? So and this is an example of saturated fatty acids. Okay, let me give you a brief intro about fatty acid, that fatty acids can be saturated. Okay, and they can be unsaturated fatty acids. Saturated means there's no double bond, like in this example there's no double bond. Okay, you can see this. And if you talk about the unsaturated fatty acids, they can be MUFA, mono unsaturated fatty acids, means only one double bond. Okay, only one double bond. And if we talk about the polyunsaturated fatty acids, we call them PUFA, means more than one double bond. Okay, more than one double bond. So first we will take all the three cases to study. Okay, so first we start with saturated fatty acids. So we know that we number the carbon 1 to the carboxylic carbon, then subsequent carbon 2, 3, 4, 5 and so on. Okay, it's just this simple. So now we'll look at another concept that which is called shorthand representation. Okay, we'll come back to a fatty acid in a minute. Okay, not shorthand representation. Okay, so I'm drawing three boxes. Okay, to represent the three things we are going to show, and these things are going to be in order. Okay, so first thing we are going to represent is, or tell according to the shorthand representation by standard system, that is the number of carbon atoms. Okay, number of carbon atoms in the fatty acid chain. Next thing we are going to tell is if it's unsaturated fatty acid. Okay, if it's unsaturated fatty acids, we are going to tell the number of double bonds it has, the number of double bonds. Okay, and the next thing we are going to tell is the position of those double bonds between which carbons these double bonds are present. Okay, so position of double bonds. Clear? So let's come back to our hypothetical fatty acid. Now we try to apply this shorthand representation in this. Okay, so I told you that the first we have to write the number of carbon atoms. So we can see that it has 6 carbon atoms. Okay, so we write 6, and then we write a symbol called colon. Okay, this is called colon. This symbol is called colon. So we write colon. Okay, we write colon, and then we write the number of double bonds. But as we can see, this is a saturated fatty acid, so it has no double bonds. Okay, so we will write a big 0 to it. Okay, so we can write 6:0. This tells us about the fatty acid. Okay, okay, so that it has 6 carbon atoms and has no double bond, and we can draw it, the fatty acid, from this information only. Okay, we can draw it easily. Now take another example of MUFA, monounsaturated fatty acid. Clear? So let's copy it, paste it somewhere. Okay, so let's make it unsaturated fatty acid. Okay, so we say it's unsaturated, and especially MUFA, monounsaturated fatty acids, means one double bond. So we apply one double bond here, we adjust the hydrogen atoms. Okay, now we'll try to name it according to the shorthand representation. So first we're gonna write the number of carbon atoms. So it's 6, this is the same. Then we apply the colon symbol to it. Okay, after colon we write the number of double bonds. So it has only one double bond, okay, between carbon number 3 and carbon number 4. So we write 1 to it. Okay, now we are going to represent the position of double bond. So how are we going to do that? First we take a delta sign. Okay, let's leave this bracket. First we take the delta sign next to the the number of double bonds, and then we look at the double bond. Okay, it's between carbon number 3 and carbon number 4. So what we do, we take the lower carbon number. Okay, we take the 3. Okay, if it's between 5 and 6, we take 5. If it's between 9 and 10, we take 9. Okay, so we always took the lower number. Okay, we always take lower number. So we write it like this, and then we can even apply in a bracket. So according to this shorthand representation, we have a fatty acid which has 6 carbon atoms, 1 double bond, and it's between carbon number 3 and carbon number 4. Okay, now we will take an example of polyunsaturated fatty acid. Okay, PUFA. So take this, copy this, I will paste it somewhere here. Okay, let's add this fatty acid to make it a PUFA. Okay, for this we need to expand our fatty acid chain. Okay, we will expand our fatty acid chain. So let's add 3 more carbon atoms, and make a double bond here. This be CH3, this is CH, this is CH. Okay, and if we adjust the numbering, this is 6, 7, 8. Okay, so now it's a MUFA. Okay, or sorry, it's a PUFA, polyunsaturated fatty acid, because it has more than one double bond. Clear? So now we are going to apply our concept and try to name it. So first thing is number of carbon atoms in our fatty acid chain. So it has 8 carbon atoms. Okay, number 1, because it's standard system, number 1 is assigned to carboxylic carbon atom, and then so on to the subsequent 2, 3, 4. Okay, so there are 8 carbon atoms. Then we apply the colon symbol, then we look for the number of double bonds. So one double bond is present here and another double bond is present here. Okay, so we have 2 double bonds. And if we talk about the position of these double bonds, we have between carbon number 3 and 4, so we will take 3, and next we have between carbon number 6 and carbon number 7, so we will take 6, because as I told you back then, just before that we will take the lower carbon number. Okay, so we take 6, we close our bracket. So yeah, our shorthand representation of this PUFA is complete. Okay, so this tells that 8 in a fatty acid. In a fatty acid we have 8 carbon atoms, 2 double bonds, one is between 3 and 4 and another one is between 6 and 7. Okay, it's that simple. So because see, these examples we just studied, these are hypothetical. Okay, because we know that the biological fatty acids contain usually 12 to 24 carbon atoms. Okay, in a fatty acid chain. So let's practice this concept in the biological fatty acids. Also we need to study some more things. That first look at this. Here the carbon skeleton, this is what, this is shorthand representation we just studied. Okay, then we have the molecular structure. Okay, so then we have the systematic name according to IUPAC. Okay, then we have common name. So do we need to study all of these things? No, we need to especially focus on the carbon skeleton, or we can say the shorthand representation. Then we need to focus on the common name. This is very important. These common names are very important. Okay, these common names are very important. Then we can ignore the structure. Okay, and you can learn the systemic name. It's easy, it's not that difficult. Okay, but most important things are common name and the shorthand representation. So let's try. So if we look at this shorthand representation of this fatty acid. Okay, this tells us that it has 12 carbon atoms. Okay, so we'll look at it. It's 1 plus this 10 plus this 1 more, so it's 12. Yeah, it has 12 carbon atoms. Then it says it has no double bond, so it's saturated. So as we can see, there is no double bond in the molecular structure. Okay, so let's take another fatty acid. Let's take this 21. Okay, so it has 20 carbon atoms. So let's see, 1 for this, 18 for these CS2 groups, methylene groups, 18, then 1 for this methyl group. Okay, so it's 20. Yeah, we have 20 fatty acids. Then this says that it has 0 double bonds, and we can see there's no double bond in the molecular structure. Okay, now we'll look at some unsaturated fatty acids. Like this, it says that it has 16 number of carbon atoms. So we look at it. So it's 1, let's add 1. It says 7, let's add 7. Then it's say these 2 more, so add 2 more. Then it's say 5 more, add 5, add 5. Then it's say 1 more. Okay, so it's 10, it's 6, so it's equal to 16. Okay, so yeah, 16 carbon atoms. Then it says that it has 1 double bond. Okay, it has 1 double bond in here. So we look at it. Yeah, there is one double bond between carbon number 8 and 9. How can we tell it from here? Because this is 1, this is 7, so it's 8, this is 9, and this is 10. And we know that we choose the lower number of carbon atom. Okay, so we will take the 9th carbon. So if it asks for the position, it's 9. We write the position in superscript on the delta. Okay, as you can see in the figure. So our concept is working. Okay, so let's take another, that this is the example of a MUFA. Okay, let's take an example of PUFA. So it says 18 carbon atoms, so we'll count. So we'll count it. Let's say 1 plus 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, so yeah, we have 18 number of carbon atoms. Then it says that we have 3 double bonds. Okay, so look at it. So yeah, there are 3 double bonds, one here, one here, and one is here. Okay, and if we talk about the position, it says 9, 12 and 15. So look at it, we look at the position. So if it's 8, okay, this much is 8, then it's 9 and 10, then it's 11, it's 12 and 13, then it's 14, 15 and 16. Okay, so we know that we need to choose the lower carbon atom. Okay, we need to choose the lower one. So this is and this is, okay. So 9, 12 and 15, okay. Between 9 and 10 we choose 9, between 12 and 13 we choose 12, between 15 and 16 we choose 15, okay. So this is the way how we apply the shorthand representation. You're going to practice this chart, okay. These are biological fatty acids. So now we'll talk about the another one, like systemic name, okay. So for systemic name we need some terms like we use deca, okay. First we need to see that for saturated fatty acid we use enoic acid, okay. And for the unsaturated fatty acid we use enoic acid, okay, enoic acid, clear. Then for the number of carbon atoms we use, let's say if it's 10, okay, we use deca, okay. If it's 4 we use tetra, you may be familiar with these, okay. Tetra, 8 for octa. So let's take if 2 for do for 2, okay. So let's, if it's 12 we first write it as 2 plus 10, so do deca, okay. If it's 18 you write 8 plus 10 octa deca, okay. If it's saturated we write octadecanoic. If it's unsaturated we write octadecanoic, okay. So let's try. So like this one is 12. So we first look at this. These are saturated fatty acids, okay. So there is enoic, okay. And if we look at the unsaturated we have enoic, okay. We have enoic. Now look at the number, as I told you that this has 12 carbon atoms, okay. So look at this, dodeca means 2 plus 10, okay. 14 4 plus 10 tetra plus deca, okay. If it's 18 octadeca, okay. 18 wait a bit, 8 plus 10 octadeca. If it's 20 it's ecosa. If it's 24 tetra ecosa, okay. 4 plus 20, so it's damn easy, okay. Now we look at, if they are unsaturated fatty acids, how we tell the position of double bonds, okay, in the according to systemic name. So one more thing that we are noticing here, there's these, apart from position of double bonds we have cis, okay. This cis here. So what is this cis and what are trans, and why, if somebody knows that what are cis and trans fatty acids, why everywhere there is just cis fatty acids, okay, why are not there's trans fatty acids? So why? So you know, this is the fact that in biological systems, or in biological membranes, we cis fatty acids are abundant, okay. They are more favorable. Trans fatty acids are not found, and there is a reason to it, okay. I already told this in the cis and trans fatty acid isomerism video. You can check it for the whole for the whole explanation, okay. So it's just a short video. So we know that the explanation is there, you can check the video. So for here we know that, understand that cis fatty acids are present in biological systems, so we will not found trans fatty acids, okay. So that's why cis is written. And what is meant by cis? Cis means that we have similar groups on the same side, while trans says that we have similar groups on the different opposite side. Like for example this, okay, that this is a double bond, so we have hydrogen on the same side, okay. And this is the hydrocarbon chain, okay. In the middle of hydrocarbon chain if we have double bond like this, okay. So they can be dissimilar, okay, because the double bond can be between any number, okay. So main thing is that we have similar group on the same side. That means this is cis. And if we have some situation like this, and this is our hydrocarbon chain, okay, this is hydrocarbon chain continuing, so here we have a similar group on the opposite side, so this is trans, okay. So cis types of fatty acids are more favorable in the biological systems. You need to understand this much, okay. So we write cis for the type of double bond. Then we write the position of double bond, okay. like 9. If we have 1, we write cis and 9. If we have 2, we write 2 times cis. Okay, then we write 9, 12 the position. If we have 3, we write like this. It will take a practice, okay, but soon you will get better at it. Okay, now for the common name you have to learn it. Okay, which one is lauric, myristic, palmitic, you need to revise it, you need to learn it, you will get better. And especially the common names are very important. Okay, there is no trick, there is no concept. Okay, you just need to write, you need to learn it. Okay, so our standard system classification is complete. Okay, everything which is here written I already told you, you can read it later. And if we talk about the omega system of classification, it says, see, for the standard system what we did, let's take our fatty acid. Okay, let's where's our fatty acid? Yeah, let's take this fatty acid. Okay, let's copy it and let's paste it somewhere here. So we'll remove all these stuff. Okay, because now we need to number it again. Okay, yeah, come done. Okay, so we are talking about omega system of classification, omega. Okay, so in omega system of classification, okay, first you need to know which is omega carbon in this fatty acid. Okay, so the methyl end carbon is called the omega carbon. Okay, first thing you need to remember that this end carbon is the omega carbon. Now how we assign the numbering? We assign number 1 to the omega carbon. According to standard system we assign carboxyl carbon number 1. Okay, but according to omega we assign number 1 to the omega carbon, to the methyl end group. Okay, so number 1 to this, then 2, 3, 4, 5, 6 and so on. Okay, so now how we name the fatty acid according to the omega system? We just look for the double bonds. Okay, let's adjust this, because let's adjust this one a bit, so it will set with our example. Yeah, okay, done. So this is 1, this is 2, 3, 4, 5, 6, 7 and so on. Okay, so what we do, we look for the double bond, okay, from the omega carbon, and like this we have first double bond here. Okay, so we look at the lower number carbon, it's the same thing, so we write omega 3 fatty acids. Okay, omega 3 fatty acids. Okay, because it's between carbon number 3 and 4 from the omega carbon. Okay, then we can have similarly as if it's between 6 and 7, if it's between 6 and 7 we can write omega 6 fatty acids. If it's between if it's between 9 and 10 carbon atom, we can write omega 9 fatty acids. Okay, so these 3 types of fatty acids are important. Okay, so we look at it, which type of fatty acids are these. We look at their examples. Okay, so if you talk about the omega series, we have, you need to learn all this stuff. Okay, now we know that how we name how we call omega 6, which one we call omega 9. You know the concept. Now you need to learn the examples. Okay, these are very important. Omega 3 are alpha linoleic acid, linolenic. Okay, DHA, EPA. Then there's also their other name, sebronic, timnotonic. Okay, if you talk about the omega 6 fatty acids, we have linoleic. Okay, this one is linolenic, alpha linolenic. Okay, and then gamma linolenic is omega 6, while alpha linolenic is omega 3. Okay, then we have arachnidoic acid. Okay, and these are nothing different, we have studied already. These are these examples here. See, we talk about arachidonic. See, wait a bit, alpha linolenic, arachidonic. Okay, this is just another way of naming. Okay, we can name them systematically too. So omega 6 and omega 3 are done. If we talk about omega 9 type of fatty acids, we have oleic acid. Okay, now one thing is important, omega 3 fatty acids are good for the health. Okay, so it's better to consume it in our diet. Now even our if we look at the cortex region of brain, so it is made up of these fatty acids. Okay, so it's good for the initial development in embryo. So it's better to have it in diet. So it helps in decreasing the following. Okay, it helps in decreasing the risk of cardiovascular disease. It helps in decrease the serum triacylglycerides. Okay, you can say triacylglyceride or triglycerides. Okay, and it decreases the risk of mental illnesses such as depression, ADHD. It decreases the risk of cancer, rheumatoid arthritis, Alzheimer disease, and all. Okay, so omega-3 fatty acids are good. If we talk about sources, if we take a non-veg source, okay, it's present in good quantity in fish oil. Okay, it's readily available in the market, you can buy it. And if you take a veg source, there's a called flax seeds. Okay, you can find in flax seeds. So this is it, we completed our nomenclature of fatty acid. Okay, if you enjoyed the video, please hit the like button, subscribe our channel, share this video. Also, you can help us in this noble service of providing free lectures and quality notes by donating only a small amount. Even a small help from your side will create a huge difference. Thank you from Biology Extrema. See you next time. Take care.